but I know that and and Wasim's lesson. I mean, sorry, that's another group. That's that's Science and Society. Who's going today? Where's my list?
Uh,
Who's going today? Okay, good. Ashlyn K, of course, and
Melissa.
Melissa. Okay, good. I know your lessons are going to be great and keep me awake and engaged. Okay, so let's just kind of go through a couple of little things. First, Ashlyn and Melissa gave me a lesson plan, and they followed the format really, really well. Okay, excellent. Those are A grade levels. So if anyone wants to maybe ask them for their lesson plan, they followed the model in the book. So maybe if you didn't buy the book, get the book. You'll see what a good lesson plan looks like. They did a great job. Um, that was handed in yesterday, and which is great. You could hand it in a day before or the day of. Um, if you and I'll give you feedback immediately. Um, the and the only thing I would say, they did the academic language excellent. It was great. And the only thing maybe you had there was syntax, which is the rules for writing and speaking. So I would kind of like put something in like um, the rules for making it, students will follow the rules for making a table. I know it sounds kind of ridiculous, but the idea is you're trying to pass the EdTPA. Okay, that's why we're doing it. That's why we're doing it. Um, you know what my position is. Once you get out, you got to cut a lot of that stuff down. Okay, what else? The structure of Ashlyn and Melissa gave me their video. You can give me my video. I have a good internet connection. It works fine. If yours is a little bit, suspect or not as strong as you'd like it, you could send me the video and I will play it from my home. If if your internet is fine, you're going to play it. Okay. So I have it. I'm going to share a screen in about a minute, and then we'll start looking at it. Now, as you're looking at it, you guys, the whole point here is we are here to support them and make them better teachers. So think about the stuff that you like. Think about the stuff that you would like to do differently if you were doing it. And I'm going to ask Ashlyn and Melissa. I'm going to ask those two questions. What do you like, Melissa? What didn't you like? And I'll ask Ashlyn, and then it goes to us, you guys. I'm going to say, hey, group, what do you like? What do you dislike? We might go into breakout rooms some days. We'll do that. Maybe not, but we're going to do it. We're not going to do breakout rooms right, for this, for today, but I just want to like get the dialogue going. And the spirit is always trying to make them better, because you don't really do a great job, a fantastic, unbelievable job the first time you do it. And so it's like notes for revision. That's a section of our lesson plan. Write those things down. And then I will put in my 2 cents. When we do all that criticism, right? I don't even like criticism because it's kind of negative, but all that positive reinforcement and also things that we'd like to do differently, that's going to be recorded. Okay. Since I am showing the video, I need to record that. So I have a big sign that says record, because I forget. So I need Ashlyn or anybody in the audience say, hey, Dr. D, are you recording? Once we start asking them what they think about the lesson. Dr. D, are you recording? Because that file I'm going to be sending to Ashlyn and Melissa, and they're going to look at that and answer some questions. They're going to analyze it. We haven't got into how we're going to analyze it yet. I plan to do that next week after, oh, here's my list. Um, yeah, here's my list. After Dimitri and Katerina. Okay. So after their lesson, I'm probably going to spend maybe a half hour talking about their critique. What do you have to do when you watch that video? What do you have to hand in to me by the end of the semester? Okay. Do we have any questions before we start? We're
I have
okay.
one question, Dr. D.
Oh, yeah.
Um,
Okay. Go ahead.
are we gonna do a critique for each of our peers' presentation? Like, is everybody doing that, or is it just like those that are working with that group.
Yeah, only the people who present, they're doing a critique, and it's individual because people will see different things. So after today, Ashlyn and Melissa will be handing into me a critique. They have all the time in the semester. It's due at the end. If they want to do it earlier, they can. But and then next week, next week, Dimitri and Katerina, after they do their lesson, they have time to do their critique. So you guys are just giving feedback. We're all giving feedback. The presenters are giving like self-reflection. You guys are giving feedback. I'm giving feedback. It's all being recorded. And then they're going to do something with it when they look at that file. Any other questions? Okay. So this is the first time. I have to really applaud Ashlyn and Melissa and also the next group because you guys are trailblazers. I've said that a couple of times. They're really important people. They set the tone and they have guts. Okay. They have courage that some of us would be like, hey, I like to see what's going on first. They're starting it off. And so I really respect folks who do that. So I think that's excellent. Okay, so I'm going to start it up. I'm going to share screen. Okay, let's see what we got here. Here's my Dropbox. And we have the lesson right here. Okay. I want to move these guys. Okay, I'll play it and I'll see if I can make it larger. Great. Okay, here it goes.
Study on membranes and what affects particle movement in today's lesson. Dimitri.
Let's start that over. Okay.
I'm back. We are going to continue our study on membranes and what affects particle movement in today's lesson. Dimitri, can you go ahead and read our do now?
The do now says, Ashlyn sprays on perfume and gets into gets in a car with Melissa, Katerina, and Dimitri. 3 minutes later, Melissa asks, is that Cloud by Ariana Grande? Using the terms diffusion, concentration, and equilibrium, why was Melissa able to smell Cloud?
All right, so go ahead and type your answers into the chat.
Now, as I read Dimitri's response,
Yeah.
I agree with him.
Actually, what I was planning on doing anyway. So, Katerina, do you mind reading Dimitri's response and either building or adding on if you think it's not? And if you agree, can you explain why?
The perfume diffused through the air from areas of high concentration to low concentration to create equilibrium of perfume throughout the air in a car. And I agree with this statement because that exactly describes what happens.
Perfect. So we are going to take these lessons that we learned about diffusion, and I know we slightly went into our osmosis lesson, and then we kind of moved on. So we're going to elaborate a little bit on that today. And now I'm going to turn it over to Miss Rowan.
Thank you, Miss Koga. Awesome. So great job with the do now. So just to bridge into our lesson for today, has anybody ever experienced getting pruny fingers? And if so, tell me what you were doing and when that happened. You can just raise your hand and then I'll call on you. Katerina.
Yeah, experienced running fingers, of course, especially when you put your fingers in a cold water and they stay there for a while. And that's what you have at the end.
Awesome, great. Dimitri, anything to add?
I was going to say the same thing. Like if you take a bath or a shower for an extended duration of time, you're going to come out with pruny fingers.
Yeah, exactly. I noticed that I even get pruny fingers if I'm washing dishes and I don't have gloves on. So yeah, totally. I agree with you guys. So given what we've learned about cell membranes and movement in and out of the cell and a little bit about osmosis, why do you guys think that happens to our fingers? Why do they get wrinkly like that? It doesn't have to be a perfect answer, just a prediction or a thought of maybe why that happens.
I would say I think it happens because water is moving out of those areas of our body.
Awesome. So you're on the right track. It has something to do with water. And that is going to set us up for the rest of the lesson and the experiment.
Amazing. Katerina, can you go ahead and read our aim for today?
Sure. The aim is as follows. How does the tonicity of a solution affect water movement?
Awesome. And so to continue on what Ms. Rowan said, Dimitri, can you read our definition from last lesson on what osmosis is?
Of course. Osmosis is the movement of solvent molecules across a semi-permeable membrane to establish concentration equilibrium.
Can you give us an example of a solvent, Dimitri?
A good solvent would be like salt.
So, Katerina, what do you think of Dimitri's response?
Yeah, that's right. That's about right.
So, Ms. Rowan and I just want to clarify. So from the previous lesson, the solvent is what the solute is dissolved in. So when we have things like salt, sugar, those are the solute molecules. And the solvent would be something such as water.
Yeah.
So if you recall, we are using the word osmosis in biology, it will always refer to water. And then so, Katerina, can you give us the definition of semi-permeable membrane?
It's the
It doesn't have to be perfect.
It's
What does it mean if it's semi-permeable?
that it's partially permeable, that
Okay.
Water can go partially. Yes.
Terrific. All right. So what I wanted to do is to go back to our pruny fingers example. So some great things that you pointed out is you have to be in water, which is the solvent, for an extended period of time. And you guys pretty much hit it on the nose, so I'm not going to repeat it again. But you notice that because we have water movement through a semi-permeable membrane, which is our skin, something happens. We're going to dive deeper into that into the lesson about what makes it. And like you guys mentioned in the diffusion lesson, our goal is to hit concentration equilibrium. Now we are going to go into our first vocabulary word today, which is tonicity. So both of you, I'm just curious, have you heard of this word used in life?
Not so much.
I think like once.
One, like to describe a non-science thing?
No, it was in science terms.
It was in science. Okay, if you were just to guess what this word meant in a non-science definition, what would you say? What are some words that you think it might be composed of?
Maybe describes like a water movement.
Sure.
I think I heard it used in terms of like muscle tone as well.
Right?
Okay, cool. So a lot of people say that word tone from it. And so tonicity can be broken down into tonic or tone, which is where a lot of people get the muscle tone from. So a tonic is a medicinal substance taken to give a feeling of vigor or well-being. So some of you might have heard of a drink in pop culture called gin and tonic. the tonic part is supposed to be like a seltzer or something that's like, wow, I feel great after this. And so I think the common colloquial thing, Dimitri, which mentioned, is that it's like, oh, I'm so toned and muscular. But actually, the root word means that you're just feeling really good about yourself and you have like a very well-being of body. And then ITY is the condition or state of well-being. And in addition, tones are also used in music. So you may hear tonicity referred to as a pattern of tones or stress in speech. And now Ms. Rowan is going to tell us how we're using it in our class.
Awesome. So thank you, Ms. Koga, for introducing the general root and meaning of the word tonicity. So, Katerina, would you mind reading the definition I have of tonicity here in blue?
Sure. Tonicity is the ability of an extracellular solution to make water move in and out of a cell via osmosis.
Awesome. Thank you so much. So this is the biological definition of tonicity and the type of tonicity that we're going to be referring to in this lesson. So just to break down that definition, because I know it could come across maybe a little overwhelming since we haven't really talked about it before, but let's go through it. So the ability of an extracellular solution. So we know when we're talking about osmosis, we have our cell, right? And then enclosing our cell is that semi-permeable membrane. And then we have the external environment. So where do you guys think the extracellular solution is located in that kind of scope?
Outside of the cell?
Outside.
Right, exactly. Thank you. So it's outside of the cell. And then depending on what's in that outside of the cell solution, that's going to cause water to either move into or out of the cell. And we know that this occurs by osmosis because we're talking about water. So when we talk about tonicity, there's three different types. There's hypertonic, isotonic, and hypotonic. And I know they all sound similar, and I know it might sound confusing, but we're going to go through it and break down each one in a few slides. So before moving on, I wanted to make very clear that when we are talking about the tonicity of an extracellular solution, we're focusing on the solute in that solution. So like we talked about before, what are the two parts of a solution? The solute and the
Solvent.
Awesome. So what's an example of a solute, since we covered that before?
An example of a solute, like salt.
Perfect, exactly. So then the last final thing is, what direction is the water going to be moving in? So when we talk about osmosis, and this might be a little counterintuitive and sound weird because of what we learned about from diffusion, but water is actually going to be moving from an area where there's only a little bit of solute to where there's a lot more of it. So from low to high, which sounds funky and it sounds confusing. And I know I get confused over it sometimes too. But if we look at this diagram that I have here on the slide, in the left-hand beaker, you can see that there's a lot less solutes in the left side of the beaker, right? And a lot more on the right side. So can anybody tell me what's happening when you go from the left-hand beaker to the right-hand beaker? What's going on with the water?
The water is moving from a low concentration of solutes to an area of higher concentration of solutes.
Awesome, thank you, perfect, okay. So now we're going to get into defining the actual levels of tonicity of an extracellular solution. So let's move on to hypertonicity. So just from hearing the word hypertonic, what do you guys hear in your heads or think when you see the prefix hyper?
Extra.
Right, extra, a lot more. So I kind of put this little example of a guy running. I guess he's running in a marathon or something, but you can tell that he has a lot of movement and a lot of energy is going into this. And you can tell that from how the photo is taken. So when we're talking about a solution that's hypertonic, what is that saying about the solute concentration, Dimitri?
There is a high concentration of solutes.
Awesome, thank you, perfect. So when we look at this beaker here, we can really solidify our understanding of this because we can see that there's a cell inside the beaker, right? And then if there's a cell, there's a semi-permeable membrane, and then the extracellular solution on the outside. So Katerina, what do you think will happen in terms of water movement in this particular scenario? Do you think it's going to move into the cell or out of the cell, and why?
I think it's gonna move out of the cell.
Okay, and why do you think that?
Because the concentration of solute is higher out of the cell than in the cell.
Right. So what did we say about tonicity and osmosis and where the water moves? Dimitri, do you want to help her out a little bit?
Water moves from the area of low solute concentration to high solute concentration.
Exactly. Perfect. So you guys hit it right on the head. Awesome. So now we're going to move to isotonicity. So given now that we know about hyper and that means a lot, what do you guys think iso is referring to?
ISO meaning probably equal.
Awesome. Perfect. Thank you. So Dimitri, looking at this scenario, which way do you think the water is going to be moving and why?
I think water will be moving in both directions at an equal sort of speed.
Awesome. You hit it right on the head. Perfect. So now we can move on to hypotonic.
Okay, so when we get into these types of things, when it's like, oh, hypo and hyper sound the same, what words have you guys heard in your everyday life that uses the hypo prefix?
Hypotonia, if I'm not wrong.
Hypothermia? Is that what you
Consider
said?
it heartbeat, and it's slow.
Okay. Dimitri, is anything coming to mind? It's okay.
I was thinking of like hypothermia, as you just said.
Oh, okay, yes. So whatever you are associating in your mind, that's going to be the most useful word for you to match to the prefix. So when you think about it, you're like, oh, so if I'm hypothermic, your body temperature is very low. You're very cold. So if you match that to it has a low solute concentration, it's going to give you a better idea of where you're going to go. So based on this beaker here, we have a 10% salt concentration inside the cell and 2% outside. Who wants to raise their hand and predict what's going to happen with water movement in a hypotonic solution?
I will. The water will move into the cell. Well, the water will move more into the cell because it has a higher concentration of solutes.
Excellent. All right, so now we are going to have you guys do an activity. So we're going to have, Rena, you can do this first solution right here, and Dimitri, you can do the second solution in the middle, and whoever finishes first, feel free to take the third. We would like you to identify in the text box the type of solution it is. So if it's like isotonic, you would just type that in. And then can you put the arrow in the direction of water movement?
For this middle one, the water is moving in equilibrium, but so should I move the arrow considering it's moving in both directions?
Dimitri, I absolutely love that you asked that. You're thinking a step ahead. Do you know how to copy and paste that arrow to make it look like them? So there are two of them? Very cool. And go ahead and check it so it looks like it's moving in different directions. If that's tricky, I'm happy to do that.
It is fine.
Dimitri, can you do the last one as well?
Sure.
That was
Katerina, can you explain why you picked hypertonic for solution number 1?
I picked hypertonic because I can see that concentration of the solute is higher outside of the cell, and that's why water is going to be moving to the higher concentration.
Dimitri, why did you pick isotonic for the middle?
I chose isotonic because there is an equal amount of solute in and outside of the cell. So the water is going to move in equilibrium between both settings.
Excellent. And then Dimitri, why did you pick hypotonic for the third cell?
I chose hypotonic because opposite to the first one in which Katerina did, there is significantly more solute inside the cell than outside. So the water is going to move into the cell.
Amazing. Any questions on what either of you said or the thought process on anyone? If you're good, please give us a thumbs up. Amazing. Our lab experiment today is we are using a gummy bear for a model for osmosis. So do you guys have your gummy bears like handy or a package? Does anyone have the package handy?
Yep.
And look at some of the ingredients and maybe why gummy bears might be a good model for osmosis.
Because mine they have 28% of sugar. I mean, 14 grams of sugar, which is 28% of daily value, which is a lot.
Katerina, what would sugar be playing? What role would sugar be playing in our experiment?
It's solute.
Dimitri, anything to add?
I would probably add an important feature of gummy bears that makes them good for this is that it is made out of gelatin, which makes it easier for water to move in and out of it, move in and out of the gummy bears.
Amazing. So you guys both hit very important things. Semi-permeable membranes are integral to osmosis. If we pick something like my water bottle right here, nothing would be moving anywhere. So we wouldn't be able to see these cool impacts of tonicity. And another thing about gelatin that Dimitri mentioned is that gelatin actually has water inside when it's mixed and cooled. So there is actually water in the bear, even though it doesn't necessarily say that on some of your ingredient labels. Maybe it does, and that's cool, because there's also water in the bear. And then water is part of our experiment. We're going to have solutions, and so that's how we're doing and testing out tonicity. And as Katerina mentioned, we have solutes. And with that, on our model, Ms. Rowan is going to go take us through our experimental setup.
Awesome, thank you. So before we get into the actual steps of what we're going to be doing, we want to make sure we have all of our materials. So does everybody have 3 separate containers?
Yep.
Perfect, okay. Do we have 2 tablespoons of salt?
Yeah.
Awesome, 1 tablespoon of sugar.
Mm-hmm.
And we have our gummy bears. Do you guys have a measuring tool, like a measuring tape or a ruler for when we measure our bears? And then you guys have a timer, I'm assuming, on your phone or on your computers. And then the camera is optional. That's just something extra you can do if you want to take progress pictures of your bears at the different time points. And then paper towels just to keep underneath your containers for when you're taking the gummy bears in and out. And then the last thing on here is the experiment sheet. Yes, Katerina.
A question. So do you have a ruler with inches? Because I also have a ruler with centimeters and millimeters.
So you can use whichever one you want, but whatever you do use, we're going to end up converting to inches anyway. So if you want to just use inches, that would be probably easiest for you. And then the last thing is the experiment sheet. So you can click on that link where it says here. And that'll take you to the Google Doc, and you want to make your own copy of it because this is where you guys are going to be putting in your predictions, your data, any observations that you have so that we can come back to class tomorrow and discuss it. So you guys let me know when you're ready to move on.
Ready.
Dimitri, you're good?
Yep, I'm ready.
Awesome. Okay. So now we're going to do the actual steps, and I'm going to move my camera. Sorry for the toggle. Okay, the lighting got a little bit better. Can everybody see my bowls?
Yes.
Okay, perfect. All right. So like I said, we need 3 containers. I'm using these small bowls. It's probably better if you use something a little bit bigger, but it's fine. It's working. So we have 3 different solutions. In our first container, we're going to do just a half a cup of water, which is this one. In the second solution, we have half a cup of water as well, but we're going to add a tablespoon of sugar, which is already in here. It just needs to dissolve. And then in the third and final solution, we have half a cup of water like the rest, but we have 2 tablespoons of salt in this third one. Okay, does anybody have any questions? Okay. So once these solutions are set up, you want to make sure that you have 1 gummy bear for each solution. And you're going to make sure that you mark, I should have marked my solutions off, but you want to make sure you write down which one's which, just so you don't get confused or forget. And then we are going to be measuring each gummy bear at each time point. Okay, so we'll go through that a little bit in depth now. So we're going to be taking 4 different sets of measurements, and each set of measurements is going to correspond to one of the 4 time points. So we're going to take measurements now. This is going to be the initial time point. You guys are going to set a timer for 1 hour from now, or whenever we finish the lesson, and take your measurements again at that point for all 3 of the bears. And then in an additional hour, so a total of 2 hours from now, you're going to take measurements once again. And then you can put the gummy bears back in the solutions overnight for the rest of the day tomorrow until we meet again. And we will do the 24-hour time period measurement together. So you're just responsible for doing 2 individual measurements. So can anybody tell me which time points those are?
The first one is in an hour, and the second one is in 2 hours,
Perfect. Great.
and 1 more tomorrow.
Awesome. Thank you.
So
Okay.
as far as understood, I'm sorry, question. So as far as understood, so we keep the bears in the water, then we take them out, we measure them and put them back in there and
Right,
take
so
them
you're-
out again in 2 hours. Okay.
Right, you're going to do that for all of the solutions. Yep, perfect. And just to be sure, when you guys take your measurements, make sure you're putting them in the Google Doc, okay? So you can write them down, but we want to have them all organized in one sheet so that we come together tomorrow. It'll be easy for you guys to input your data and analyze it. So we just included this additional slide here just to show you guys the 2 measurements that we want you to take for each of the bears are diameter and length, which is simple enough, but just in case anybody forgets what we said or just is a little confused about it, those are the exact measurements we are asking you guys to take. Does anybody have any questions? Awesome, okay. Okay, so just to make sure that we are good with recording our bear, what we're going to have is in this section right here. So don't worry, we sent you our slide deck and it will be right here. If you say click here, this is the sheet you're going to record your data. So it's going to be an Excel spreadsheet that looks like this. So on the first tab you will see this Rowan sample. Guys, my internet is slow. So on the bottom you will see individual tabs. So the first thing you see will be Miss Rowan's sample. And as you can see, this is in inches, length of her bear, for the one she's putting into the water. So, Dimitri, first up, I'm just gonna click on you. Your tab would be right here and that it's empty. So right now, go ahead and take the measurement of your bear at its start point where nothing is messing with it. And then so just take your ruler and measure the length and the width of your bear and go ahead and record that in and give us a thumbs up when you have it in.
I guess I put the same numbers in where it says 0 hour in sugar water and salt water as well, right? Because it's the same.
Yeah, if all your bears are the same. I don't know if there's variation. Maybe the producer made one like a little bit more robust than another bear. But if all of them are the same, that's fine. And as you're doing that, Katerina, if for some reason, as you guys are putting in your 1 hour or 2 hour data, this graph on the right-hand side is not populating for you, please shoot me and Ms. Rowan an email because we need to fix it to make sure that our data is good for the next class. Thumbs up if you're good with the data sheet and understand how it works. Amazing. Okay, so right before we leave, Ms. Rowan and I wanted to hear you make some predictions. So you don't have to say them out loud right now. Take like a minute of think time. And we wanted you to fill out in this top part of the document, what do you think will happen to the bear and why in your water solution, a sugar water solution, and a salt water solution? So move up the tab so I'm not displaying one of your work.
So we have to predict the final result, right?
Yes, correct.
Mhm. Made me sing really hard.
Well, that's good. That's okay.
I'm picking at Mitch's answers. But I'm not changing mine. I'm not changing mine, no.
So,
It sounds like if you're wrong.
Dimitri, can you share one of your predictions that you feel comfortable sharing?
My prediction for the gummy bear in just the water solution, I believe that this gummy bear will grow the most in size compared to the other, gummy bears in the other two solutions.
Can you elaborate on why?
I believe that it will grow the most because the other two solutions contain other solutes in them. So such as in the salt water, it contains 2 tablespoons of salt. And I feel that this gummy bear will grow the least in size because of the presence of a lot of solute compared to the gummy bear in just water, which has no other solutes inside the solution.
Katerina, do you have anything to add to Dimitri's prediction?
Well, I can agree with the statements with the salt water, so the gummy bear and the salt water will get the smallest. I did not notice that in my prediction, but I would agree with Dimitri, but like this is. I think that will get bigger in water, the gummy bear, but I'm not sure about sugar because we have the same solute, and I'm not sure about the concentration of the solute in water. We take just 1 tablespoon and a half cup, and I'm not sure what's the concentration in a gummy bear. So how is that gonna equilibrate? So I still think that the gummy bear will get smaller given its size, and that the I'm sure.
Predictions, because your thought process, Katerina, with everything that we were discussing, you're thinking about the solute concentration inside and outside and using that ingredient label to look at the solute concentration. So this is all really great. And all we're going to do is we're going to run this experiment and figure out the answers tomorrow and dive deeper into those questions you have. Does anyone have any questions before we sign off from today's lesson?
No.
Can someone summarize what you're going to be doing after you move off? What 2 data points you're collecting tonight?
Tonight, we are collecting the length and width data of the gummy bears in 1 hour and 2 hours, and then later in 24 hours.
Okay, this is Dr. D. I'm gonna pause it for a second. So this is kind of cool because occasionally students will come to me and say, hey, I got a really good activity, but it really goes like, it's almost like a 2-day thing because they have to like maybe grow a lima bean or, you know, it takes long for a reaction to occur. And so this was one of them. And so this is kind of interesting. It's kind of like probably a 2-day lab, but so we're not going to, you know, we're not going to see them make the recordings. We're going to kind of get back on a second day. So we could kind of, you know, it's going to be like a time dilation in a way. So this is pretty cool. This is kind of unique. It doesn't happen very often, but there's a lot of experiments, especially in living environment, that take time to occur. And that's okay. That's totally okay. Remember, I'm trying to teach you guys how to do a lesson in 45 minutes, right? That model, you know, flex it 1, 2, or 3 can be used for 2 days, for 3 days, all the way for a week. If the experiment is that long, you might want to take a lot of trials. Okay, do a lot of repetition. Depends on the situation. So this model is, I'm teaching you how to do 45 minutes because I know the practicality that you guys will be facing as teachers, that yes, there'll be regents. You need to move through the curriculum. A principal observes you. They want to see a 45-minute lesson. You go for a job interview, they want a 45-minute lesson. So it's really valuable to know how to do that in 45 minutes. So this is unique. Doesn't happen very often. I like it. Let's see what they're going to be coming back now.
Any other questions or anything? Okay, well, thank you guys for participating and being here, and we will continue the lesson tomorrow and pick up and see what you guys do.
All right.
Okay, thank you.
All right, good night.
All right, everybody, so welcome back to class. So how did everybody's experiment go? Did it go well?
Well, for the majority.
Oh, really? Okay.
Yeah, I was talking to Miss Koga before class, and at the 24-hour mark, when I checked my bears, they are a vast majority of them are basically disintegrated.
Really? Okay, great. So
Mine were good. The only one which we used the water for, we put in the water that just broke in half, but I was still able to take it out and measure it. So.
Okay, great. So we definitely have a lot to discuss then.
Okay, so what we have here is an aggregate of all of our data. So Ms. Rowan's data, my data, and y'all's data are all in this for averages. So we are going to turn it over to you guys, and someone just start us off with something you observed. And it can be either in your own experiment that you want to bring up or what you notice in our graphs.
At least in looking at all of the graphs side by side, or at least these averages, clearly compared to the water and salt water, the water and the sugar water, the bears in salt water decreased in size due to the higher amount of solute outside the bears.
Some great observation.
Yeah. The bears in water, they increased in size the most in comparison with sugar.
Why do you think that is, Katerina?
Well, because the solvent was not containing any sugar, it was just pure water. And that's why the bear was absorbing a lot of it. And that's
Great observations.
And then how about if we use our vocabulary words to describe some of these solutions?
So what type of solution would you guys classify the water solution as?
The water, wouldn't that be a hypertonic solution?
And why do you think that?
Because there are more solutes inside the gummy bear than there are in the water surrounding it.
Okay, so if we have the gummy bear with a lot of the solute on the inside, and the solution doesn't have much of the solute on the outside, right? So the extracellular solution doesn't have a lot of the solute. So do you still think that's hypertonic?
No, it's hypotonic.
Right, exactly. Awesome.
Katarina, I saw you shaking your head. Can you elaborate on the
I was just
argument?
no. I was just going to say that it's a hypotonic solution because we wouldn't have that much solvents present in water.
So, okay, so then what do we think
Yeah.
about the salt solution? I mean, the sugar solution.
I think it's also hypertonic.
Would it still be hypotonic but closer towards equilibrium?
Well, I would think that while there's sugar both in the bear and in the extracellular solution, I think that there was more solute on the outside, right?
Okay.
Compared to just one gummy bear.
Hmm.
Would you guys agree with that?
Yeah. So then that would be a hypertonic solution.
Right. And then the salt?
Hypertonic.
Yeah.
Exactly.
All right, and why is the salt hypertonic?
The salt is hypertonic because there was more of the solute outside of the gummy bear than there was inside.
Excellent job. And Dimitri, it was also great because you said that in your previous observation.
Yeah.
The biggest things in terms of the solute and what it looks like in the solution is how we're going to describe tonicity. Anyone else want to add any cool observations they saw in their bears?
I personally thought it was interesting how as time went on, it seemed like more of the artificial coloring in the bears seemed to dissolve out of them and into the water surrounding.
You know what that would be from our previous lessons? Diffusion or osmosis?
Yeah, that because it's artificial coloring, wouldn't that be diffusion?
Exactly. Perfect. Great connection, Dimitri.
Thank you.
Can you remind us of what our aim is for today?
Our aim is to answer the question, how does the salinity of solution affect water movements?
And so we're going to turn it over to you.
So,
So how about we go through each of the different tonicities? You guys can do it that way. So we can go through the hypertonic, isotonic, and hypotonic to keep it more organized.
So
Okay.
in a hypertonic solution, for example, salt water, the water goes out of gummy bear to the solid, if I can put it this way. The word solid
So the water
to the
the
solid.
gummy bear to the outside solution.
The outside, yeah.
Okay, and then if we're using the term solute, where is the higher solute concentration? Inside
Outside.
or outside the,
In the salt water, outside of the bear. this salt concentration is the most. That's why water goes out.
Isotonic.
Water doesn't flow in our experiment. Our solution was close to isotonic. That's why still water went out. Went in because the concentration of solid was bigger in a bear, was higher in a bear. That's why we got a bit water in the bear. But in isotonic solution, in ideal solution, the water wouldn't flow, it would just stay the same.
Great job.
Do you know a term that we could use that starts with an E?
Equilibrium.
Equilibrium.
Perfect.
Amazing. Okay, and for a hypotonic, Dimitri, can you take the lead on this one?
Yeah. So in a hypotonic environment, the gummy bears had a higher concentration of solute than the water surrounding them. So the water would move more into the gummy bear.
Terrific. So we just compiled our class notes, so you always have these to look toward when you're answering this question in the future for water movement.
Awesome job. Okay, so now we're going to move on to our homework assignment. So can I have a volunteer to please read the homework out loud?
Sure, I will. The cells that make up slugs are filled mainly with water and are surrounded by very permeable membranes. Using the concepts of tonicity and osmosis, please do the following. Explain why placing salt on the slug would ultimately lead to death by dehydration. And 2, draw a picture of a slug and using arrows to depict where the water is moving.
Great, thank you so much. So does anybody have any questions on that before we move on to the final part of our lesson? All good?
All right, so what we're going to do is we're just going to go in alphabetical order. So Dimitri, you're going to be heads, and Katerina, you're going to be tails, and we're going to do a virtual coin flip to answer some questions. So we have heads. Dimitri is first up.
All right.
So,
All right, so for the first question, what would you think would eventually happen if this gummy bear shown here was placed in a pure water solution and why? So we can think back to what you guys observed from your experiment and what we discussed in today's discussion. So what do you think, Dimitri? What would happen?
The gummy bear would expand in size due to the higher level of solutes outside of the bear in the water.
Okay, awesome, great job. And so what part of the gummy bear is allowing that water to move into the cell, into the gummy bear, the cell in this case? What allows it to do that?
The osmotic water pressure. Well, the osmotic pressure in the environment.
heads again.
All right, fine.
Dimitri, have you heard that Isotonic Beach was 2021's ideal beach for gummy bears? What will happen to Ozzy when she takes a dip and why?
In an isotonic environment, water would move in and out of the bear at the same rate, so that this bear would stay the same size.
Excellent, and that is probably why it is an ideal beach for bears. Terrific. Let's try again.
I guess I can take the lesson. Yeah.
So, Katerina, what do you think would eventually happen if this gummy bear here was placed in a 70% salt, 30% water solution, and why?
So the gummy bear will shrink in size ultimately because the amount of solute outside of the bear is higher. So water will be going out of the bear outside.
Awesome. And what kind of extracellular solution would we call that then?
That's going to be a hyperdynamic solution.
Awesome. Fabulous.
All right, and last question. It's in pure. What is ethnicity?
If the raisin is placed in pure water, the water will move into the raisin, hydrating it,
Mm-hmm.
and it will be a hypertonic solution.
So hypertonic means that the outside of the solution has a lot of.
Oh, yes. So it's going to be a hypotonic.
Exactly. Because there is less solute in the solution. Excellent job. This ties right back into our talk about the pruny fingers, because that is what's going on. The water is rushing right back into our pruny fingers. And if you ever wanted to rehydrate your raisins, this is the way to do them. And they are going to get puffed up just like our fingers.
All right, so does anybody have any questions?
No.
We're good with the homework assignment?
Yeah.
Okay, awesome.
All right, thank you so much for joining us for our lesson today. And we are going to continue our discussions on membranes and molecule movement tomorrow.
Thank you, Ms. Koga. Thank you, Ms.
Okay.
Thank you.
Thank
Bye.
you guys for coming.
Okay, let's, I just want to make sure it's paused. Okay, good, it's off. Okay, pretty awesome. Okay, so I'm going to ask Ashlyn and Melissa. First of all, Ashlyn and Melissa, have you guys talked before?
I haven't.
Melissa, you haven't.
Nope.
Okay, what about Ashlyn K?
I have talked before.
Yes, you have that teacher voice. I don't know if anyone noticed.
Thank
But-
you.
Kind of had that's the voice everyone's going to get eventually. So you kind of had that command and presence and all those things that we want. Okay, so I'm going to start with Melissa. What did you like about your lesson?
I like
You know,
the
first of all,
actual-
sorry, time out. I have to record this. I have to record.
Oh yeah, okay.
Okay, so Melissa, what do you like? Wait, hold it. Record on this computer. Okay. Okay, Melissa, what do you like about your lesson?
Well, I really liked the lesson in general because we really went with an experiment that we were interested in and then kind of built off of the experiment. I think that it was just interesting. I think it was relevant for if you're doing it in a middle school or a high school because it's gummy bears. I think the overall lesson itself turned out like we were hoping it to. The only thing I would say is that I think we maybe
We'll
could have
sa-
turned a
we'll
little
save
bit
that.
more. Oh,
Save-
okay,
Yeah,
sorry.
save that other part just for a few
Okay.
seconds. But so Ashlyn, what did you like about your lesson?
When I assess like how my lessons are when I teach normally, I go first based off student engagement. And Katerina and Dimitri, like they told us that they had a lot of fun. And like I know it's hard to come through like when you guys are watching it, but like we all had like a lot of fun doing the lesson. And I think that Katerina was making those points about like, oh, this is a really like thought-provoking question because I'm trying to think based on the sugar content. To see her like making those applications, I thought was really rewarding and that she was like really grappling with the research. In addition, I like that Melissa and I picked a lot of examples that were more relevant to real life, not just like, let's look at these tubes and like see what they are. So we used like pruny fingers, raisins, slugs, just to get the point across that like this lesson is relevant to real life. Both of us also added in interaction slides to make sure that we weren't talking the whole time. And we tried to connect the experiment and show purpose with it for like why we're using the gummy bear, why it's a good model. So I thought those were all the strengths of our lesson.
Okay, wow, you had a whole bunch. What did you like? What would you like to do differently, Melissa?
I think, and we practiced it. We practiced it once before we actually recorded it, but obviously things always turn out a little bit differently when you're actually doing it. I think that what we could have done a little bit better was maybe saving a little bit more time for discussing the results. I feel like I don't think we rushed it, but I think we could have, I think we covered all the bases, but I think we could have spent a little bit more time discussing the results. So that's like the biggest thing for me. And I
Okay.
think that something that we discussed when we met with you last week is that the vocabulary in the lesson can seem overwhelming because it's tonicity and then the 3 types of tonicities. So that's the only other thing that I wasn't over the moon about, but I think that it turned out as best as it could.
Okay. Okay. Good comment. Ashlyn, what would you like to do differently?
I think just based off like our summative assessment, so there was still a little bit confusion on some of the terms. So that told me that we probably would have been better off discussing either the 3 terms on a different day and just get them really comfortable with the solvent-solute dialogue, especially since that question for the review part was not answered correctly. So if I was like actually teaching this lesson and what I thought my students should have known from the first day like didn't carry over, I would have just modified my whole lesson and not tried to introduce more material if they already didn't master that. Because there was still like a little bit of slip ups throughout the lesson using those 2 terms. And I think that's integral to understanding the lesson. So I would have just either saved it for a different day or made sure they had a very good understanding of what each of those terms were before we jumped into the lab.
Okay.
And then to build off on Melissa's point, I wish that we did have more time for discussion. I think that's the most valuable part of an experiment. So to actually have time to split our data and have them actually like grapple it and not have all my writing like on one slide would be more productive. Melissa actually suggested for them to do a turn and talk originally, but we were running a little short on time. So we kind of like axed that aspect of it. And then in
I'm gonna cut. Okay, Ashlyn, I'm gonna cut you off because no one's gonna have anything left to say.
Okay.
In terms of comments. So you're very thorough in your critique. A lot of times if we're in 705 and you're doing a lesson, a lot of people are like, they can't even reflect because they just did this lesson and like, I don't really know what to say because their minds are going in a different pace and they're in almost a different place. But through Zoom, and since you did this for a week, you're probably subconsciously also and consciously kind of thinking about how this could be improved. And so you have a whole bunch of things to say, which were all really great. But I want to get, I want us, the rest of the class, to kind of turn into people who can critiquers. So what did you guys think about? Now I'm going to turn over the class. Think about the parts of Flexit. So was this Flexit 1, 2, or 3? Let's start off with that. Flexit 1, 2, or 3. Where was the vocabulary?
This was number 2.
Okay, so Flexit 2 says the vocabulary comes before the activity, right? That's totally true. So this is a Flexit 2. So now start to, let's kind of go piece by piece. Would you guys, I'm gonna say any comments that, things you liked, not things that you would do differently. Let's keep it totally positive, but let's kind of think about the parts. Okay, what about the do now? You might want to give a thumbs up. You might want to say something. You might do whatever you want to do, verbalize. You like the do now. Okay. You could also critique when we say some things that you'd like to change. You might want to change the do now. But any comments on the do now? Okay. So we had the do now.
I like the do now because the students had to use vocabulary that they knew before. And it kind of helps reinforce them when they're able to put it into like words and use it.
Okay, so that vocabulary that was going on there, where there's a couple of words, equilibrium, this and that, was that a bridge to yesterday, Ashlyn? Yeah. Okay, so that was a bridge. Remember, do nows can be a bridge to yesterday, or it could be a bridge to today. All right. Okay, so that's one comment. Okay, then we had the aim. Did you guys feel like the aim was expressed? Was it in the form of a question? Yes. And what about, was it listed at the bottom, like throughout the lesson? Yes, it was kind of nice, right? It was kind of small. It was kind of like gray print, but it was always there. Okay. What about the motivational opening? What do you think about that? What was the motivational opening?
It was the wrinkly fingers.
Yeah.
I thought that was very, very nice because everybody's had them. It's very relatable.
Yep. You know what I wrote down? I said, hey, I wonder if you can make a experiment out of wrinkly fingers. Like you put your fingers, you measure, you do fingerprints, right? And then you put them in and you clean them off. Then you like one finger, and then you put them in a solution, take it out after an hour, and then do your fingerprint again, and then put it in there for a longer time. I guess it's not practical, but I was kind of thinking like, oh, that was really cool. So it got me thinking about like an experiment. So I thought like, can we measure pruny fingers? Anyway, let's go from, okay, so the motivational opening was definitely great. Okay, let's go to the next part, which is what? What's the next part of a Flex It 2? What did they do next?
Didn't they introduce the vocab?
Yeah, okay. So you guys comment on that, on the vocab. Tonicity. Remember the music, tonicity, that's those slides, and looking at the 3 types. And once again, anything that you liked about that?
I definitely liked how they tried to relate the root of the word to, like pop culture. I thought what Ashlyn said about, gin and tonic, maybe the kids would see some connection to that. And also like the breakdown, when Melissa, and Ashlyn like talked about each of them and compared it to an example. I think that was really good too.
Okay, good. What about, okay, so vocabulary, the breakdown of the word, and then also breaking down like hypo and ISO and having, what was nice about that breakdown? What did they have to help you?
The visuals.
Right, the visuals. So to try to like, because it's confusing, right? Which one is which? But if you could attach a word to a visual, that will help you remember. Okay, after that, we have the modeling of the procedure. Okay, any comments on the modeling? Did you understand what to do if you were kind of imagining to do it? Okay. Did they any special techniques they used when they modeled the procedure?
I think Melissa did a great job on modeling because she used a lot of repetitions. She was constantly reminding of what measures to take, how many times, what to do step by step. And she repeated that like a few times so students could remember.
Yes, and also she checked in, right, with people like, what was that? Could you summarize that procedure, or what do you
Any
have
questions she asked?
Yeah. Okay. So they modeled the procedure, and then they took a break, right? So they said, okay, the data. They said when you collect your data, it's going to go into a Google document, and you have a link, and you have to put this data in. All right. And so they kind of left, and then we came back the next day, and the data was already inputted, and we suddenly saw a graph. Okay, we suddenly saw a graph. So talk to me about that. Did you like that? Did you like that Melissa and Ashlyn chose Google Docs? Did you like the graphics? And once again, if you don't, we'll hear about that in a second. But did you like it? Whoever liked it, please talk. Please comment.
I like the Google Docs. I think it was a good visual. The only thing that I would have done differently is that they had like the teacher answers with the student data. So the
Okay.
students could go to the teacher tabs and look at all the data and see like the patterns. I would have omitted that.
Okay.
It kind of ruined the surprise.
I think that's a really good point. I think we're going to talk about that in a second, but Google Docs seemed like it was an effective way. And then after the data, their students are trying to use the vocabulary to interpret the data. Okay. And then it kind of moved into answering the aim. Any comments about how they had people answer the aim? Any comments that you liked in that, or that area, that section of the experiment, anything that you liked? Okay. Then they moved into the homework. Did you like the homework? Okay, Carolyn is saying yes. That was pretty cool, right? With the slide.
I love that. I thought that was great.
Yeah.
We've all
Okay.
seen the slugs.
And then
Not that I do that.
I know we used to do it when we were kids. I had a pet slug when I was younger, just to let you know. We had it in a bucket. I put it outside, and then when I woke up the next day, it was gone. I was trying to follow its trail, and I lost it. I lost it in the grass. My poor slug. Anyway, so after the slug, we had the flip the coin, right? The game. That was really great. What do you guys think of that?
Yeah,
That was
that element of just like the chance, of like it could be either Dimitri or Katerina. I think that made it more engaging.
yes. And that's something that, you guys should steal. You got to steal that. That was a really easy thing to do. And it gave that little extra that people like, they almost forgot they're being asked questions. Okay. So that's the lesson. Now I want to hear from you guys. What did you like? Just like other things. Let's just talk about those. I went through the pieces, and this is probably the 5th time I've done that. So we can ingrain it into our system, into our brains. We have like flex it. Oh, it's DeMeo just showed 3 flex it. Oh, I'm overwhelmed. I don't think so anymore because we went through it over multiple times. And so that's kind of why I want to do it. But I want to hear like, let's free speak about what you liked.
Can I say something?
Yeah,
As
sure.
a former student of Miss Koga and Miss Robin, it was not just a lesson, it was a constant discussion. They were constantly asking open-ended questions. It was pure inquiry. And that made us think a lot. And that's what makes this lesson really great and engaging.
Okay.
So that everybody has to do.
Okay. More comments. You could comment about how they spoke to people, their voice, their organization, anything you want to talk about. Like, I'm not hampering you at all in terms of like what little section anymore. Just express what you thought was a positive thing that they did.
I think they transferred attention between the two of them really, really effortlessly. I mean, it was clear that they had they had their plan. They both knew the plan, and they both knew exactly whose turn it was and when. So it was like there was no lull in the lesson. It was just like, take it from here, got it. And then they just kind of went with it.
Excellent teamwork. Excellent teamwork. What else? What else do you like?
Well, I also thought that they spoke in a really nice cadence. So it was excited and engaging, but it wasn't too fast, and it also wasn't cloying, right? Sometimes people could get, for me anyway, a little bit too excited. And I just thought the tone and the cadence and the level of organization was all made it seem really professional, and like they really knew what they were doing. They really cared about the subject.
Yeah. All that stuff that Caroline's mentioning comes through your voice, comes through your eyes. Okay. There's not a lot of, hand motion because we're in Zoom, but that all was very, very apparent. Okay. What else? What else do you guys like?
I think when Dimitri noticed that one point about the food coloring, I like how they transitioned. I like how Ashlyn like grabbed that and like related it to past ideas, maybe a previous lesson, like if this were an actual class. I think that was a good like catch. I'm sorry about the dog, but I think that was great.
Okay, good. More comments. This is a really strong lesson. A lot of good things happened in this lesson.
I like the positive atmosphere when students answer the question and bring up their thought. The teachers are very positive, and they use praising word to encourage the student to try, which is very good for a student to keep trying, even though they may not sure what the answer, but the teacher use very encouraging words to like ask the student to try. Yeah.
That's a big deal, right? That's a really big deal, because if you're a positive, if you give positive responses, students are more likely to talk, to respond to you, to participate, and then you find out what's in their mind. Okay. What about prior knowledge? Did they tap into prior knowledge? Okay. How so? How did they tap into prior knowledge? When did they do that?
Well, that was the do now, right? With the perfume and how it diffused and moved.
Okay. There's another spot too.
The hook with the pruny fingers, like, how do you think this is happening?
Okay.
Because I think they have all, I'm sorry. They've all experienced it, right? And then they could be like, oh, we did like osmosis in the previous lesson, like maybe try to connect that to this do now.
Okay. What else? What other opportunity do they have to express their prior knowledge.
They also talked about like solute and solvent and make sure that the students have like a firm understanding of like those two concepts.
Okay, excellent. I was thinking about predictions. Every time you ask a prediction, you're kind of tapping into that. So they had a nice, now the predictions were a little bit different, right? I think Dimitri had some different predictions than what actual happened, in terms of all of them. But that was kind of cool. So every time asking predictions is a great thing to do. In terms of things that you like to do differently. So let's start with Veronica. She said that, I think one of the, I think Ashlyn or Melissa hit a tab where it showed all the data. How do you guys feel about that? Would that be something that you would want to fix? Or like if you were doing the experiment, you would do differently?
I agree. That was my third point after
Okay.
talk anymore. I completely 100%. I realized that as I was like filming it and I was like, great.
Okay. So does anyone concur? Does anyone agree with that? Like, hey, maybe that tab shouldn't have been hit on Excel?
Sorry, you can go first.
Yeah, actually, I do agree with that because that's one of the things I wrote down in my notes that, you give the students the results before, so they kind of have an idea of what's coming.
Right. So that was just an accident. That's an easy fix. Okay. But there's something very powerful when the teacher is doing the experiment at the same time the students are. Like you start putting in your data, you're making your measurements while other students are making measurements. I think that's totally cool. I think it's like, hey, the teacher's into this. The teacher, and the teacher has data and we have data, we're kind of together. But when you show that data that you did, maybe the teacher did a day before, it's like, let's all the air out of the balloon. It's like, oh, the surprise. Oh, it's like, why are we doing this if it's already done? So it's amazing how just the timing of that data, the difference in like, I don't know, emotions in terms of like, how do you respond to data? How do you feel about the lab? Like if the teacher already did it, we saw all the data, it's like, I don't have much motivation. But when I see the teacher doing it with me, it makes all the difference. So that's really cool. I'm not belaboring this point. This is not a major criticism, but it's like a big point for everybody. It's like, a lot of times you'll be walking around the room and you won't have time to collect your own data because you're making sure that students are doing things correctly, and that's okay. But if you are collecting data, do it with the students. It's very powerful. Okay, what else you'd like to do differently if you could do it again? What else?
I thought it was really cool how the data, like as they input the data, it went into the graph. And I understand there was a time issue, but I think that would have been cool if you could have showed that after the students made their own graph. And that might be a cool feature if you've been doing a lot of these experiments and the students already know how to properly scale and make a bar graph. I think that's a really time efficient thing to do. But I think it's really beneficial to have the kids make their own graphs instead of having it like automatically do it. Again, it's a super cool feature and I thought that was really interesting, but I do think that it kind of took away from having the students make their own data tables and, graphical representation of that.
I think that's a good point. I think, we could always kind of pretend like this is in the middle of the year and the kids know how to do graphs, but it's a good point. Like this is not something that you want kids to do their own graphs in the beginning of the year, in the first 2 months. And then you kind of might move into something like this where it's aggregated. Okay. Other comments you'd like to do differently?
This is a nitpick of mine, but I was just like wondering. I wonder why it was an interesting thing that you guys chose inches as the unit. I'm just thinking like, usually we use like the metric system and not like the American one. Was there like a specific reason or was it just out of convenience?
We really didn't discuss it. I think we just kind of said, all right, we're going to go with inches. So there wasn't really anything behind that.
Okay. No, I was wondering. Thanks for clarifying.
Okay. What other comments? What would you like to do differently if you were doing it?
There was just this like one slide towards like the beginning of where they were talking about the 3 words and there was only one image. So that was like just like the one thing that kind of confused me because I'm not really like the bio person. So I guess I would have separated that one slide, but the next two slides, they were really well played out, like the ISO with the image and then the hypo with the image. I don't know if you know what I'm talking about. Like the first time the three words came up, there was only that one image. So I'm like, wait, which one is this showing?
Of the runner.
I don't know if it was actually.
I
like
know
the
he's
two-
talking about like right before Melissa was explaining what tonicity is in general. It just had
Yeah.
a slide with like one example on it.
Okay, okay. More comments, more comments. This is the kind of deep dive we're going into. What are the comments?
I don't know if this is a comment, but I was thinking about the inability to like remember hyper, hypo, and well, ISO is easy, right? And I've always struggled with the same thing, and I feel like I constantly need to look, like if I have to know that, I have to look it up. So I was wondering what you thought about taking the class, like letting the class like pick mnemonics or think about ways in which they could like more actively remember the difference between hyper and hypo. When you have something that's like kind of similar, the terms that are similar, but right are like exact opposites.
I think that's a good point. Like, how do you remember these terms? And I think the images help, but maybe some sort of acronym like you're talking about,
Right.
like, hypo, and like maybe combine a word. What might be really advantageous is to keep on saying to the class, please write this in your notes. Please write this in your notes. And what you might want to do is like put those three words in a box, and tell the kids it's going to be hard to remember. So we're always going to flip open that page and make, if you have a marker, make it yellow, because it's hard to remember. And so when you answer questions, I'm going to give you time to open your notes and look at that definition. You might even want to have, when you give an assessment, you might allow students to have those definitions for those words because they're really hard to remember. Okay. But a thing that I would say is like, hey, copy this in your notes. That should be like a mantra. Copy this in your notes. Are you guys copying this in your notes? Billy or whoever is in your class, let's, copy this, It's like a mantra. Keep on saying that. But I totally understand, Carolyn. That's hard for me. It was hard for me to remember. And I don't think it's anything reflective of the teachers at all. It's just like, you need to write it down, Other comments.
Well, I also sometimes think it helps to hear things in different ways, right? Like some people, I look at pictures and maybe it helps, maybe it doesn't, but I tend not to to look at graphics. So that was what got me thinking, like how have hard definitions, right? How do you bang it into their heads?
Yeah. More comments. Any more comments that you'd like to do differently?
Dr. D, can I quickly respond to Caroline?
Oh yeah, sure.
I think another reason why it's like hard to distinguish is a lot of people use examples that also have the hypo. So like if you say like hyperarrhythmia and you don't really understand what that means unless a family member has it, it's like really hard to like remember because it has no meaning to you. But if you say hyperbole, there's not really like a hyperbole, So like that is like, oh, here, this is what it is. It's like an exaggeration. It's like you're extra. So if you can pick words that don't have like a counterpart of that same word, I think that also helps if you're into like the more like linguistic side of it.
And it might not be worth, trying to create a crazy acronym. It might just be like, hey, we just have to look at our definition, I thought in terms of the lesson, I think, let me talk about the things I like to do differently if I was doing it. I would probably, when you have a graph, right, you had two graphs together, only show one. And I think, Ashlyn, I think you're kind of mentioning this, but only show one of those plots. And then what you could do is first of all, you'll have more space. So you could change the axis a little bit better so that you could actually see a trend. Because if you see the one for the salt, people could argue, hey, there was no change. And that was just because there was a slight little dip at the end, and people could argue there's no change. So you want to exaggerate that. You want to kind of bring that out. And the way you do it is you increase the graph, you increase you try to, first of all, you try to make the range a little bit smaller. Like I think it went to 2.0. So you might want to go to 1.75 and make those differences more pronounced. Okay. And then have people explain that first plot. Okay. I think what was it? Length, I think. And use the vocabulary words. And guess what? The next slide is diameter. And guess what you'll ask? Use the words again. So you're giving students another opportunity, maybe different students in the class, to use the vocabulary to interpret the graph. Another thing that I might say is that, let's see, you might want to only do, I don't think we had an example of an isotonic. So you might want to think about just doing salt water versus regular water. Okay. And so, and kind of like simplify it. It might take, a little less time to do, but you might just, salt water versus regular water, and you get a big difference. And you can just look at that if you want to simplify things, because, it wasn't like you had 3 different ones and we had hyper, hypo, and iso. We had no iso, which is cool, which is fine. So I think that might be something you want to think about. Once again, ask people to write, copy stuff into your notebook. I love the picture of the bears, right? The picture of the bears. So you had the different size bears, but you know what? Before you do the graphs, show the pictures of the graph of the bear. So go from qualitative to quantitative. So in other words, just move that picture of the bears. I know you showed it when you were answering the AIM. That's data, okay? It's not quantitative, that's data. So you want to move that up before the graphs. And then what you're basically doing is you're taking that qualitative pictures and you're quantifying it into a graph, and then you're asking students to interpret it using the vocabulary. So if you just move that up, I think that would be a great idea. A lot of great things in this lesson. I was kind of blown away. This was a really kind of amazing lesson in terms of like a lot of care went into this, a lot of teamwork, but I was really blown away by how they brought us in. They made us feel comfortable. They were positive. I think King you said how they were like affirming people's responses. That is huge. They were knowledgeable about their information. They had a really nice structure, from the Puni fingers to those interactive arrows that you were moving around and you were filling in. I really like that part. To water predictions. I love when you said the water bottle. That's not semi-permeable. It's like, for me, that image clicked. It's like, oh, it's plastic. Not everything is semi-permeable. The gummy bear is. So I like that kind of contrast. A lot of great things on here. The slug and the virtual coin toss, which other people mentioned. This is a super strong lesson. This is like, we're really starting off on the right foot. Okay, you got it down. You got the script down. You got Flex It together. You did that. Yes, you can do some minor tweaks to it to elevate it. I kind of expect that for every single presentation. But outstanding job. I really have to applaud you. Excellent, excellent, excellent work. Okay, so you guys should be super proud of yourselves. Great beginning. I think it kind of like it shows the rest of the class what we're trying to do here. Okay, especially Melissa, I have to give kudos to you. You never taught before and you did an amazing job. Ashlyn, how long have you been teaching now?
For 3 years.
Okay, so 3 years. Okay, and so really, and a lot of people here are pre-service who don't have very little experience. So it was really nice to have you guys, Melissa, be teamed up with someone with experience. Okay, but I'm really glad that I would love to have people who have experience to kind of go early, because that sets a really nice bar for us to reach. Okay. This is the type of class we're going to be having for the rest of the semester, kind of like these deep dives into the lesson, what you liked about the lesson, and what would you like to do different if you were doing it. And there's like these 3 levels: starting with the students who presented, getting your comments, and then following at the end with mine. And once again, all this is being recorded, and a lot of this, I'm going to be asking you to reflect on what everyone says, and you could agree or disagree, okay? It's not, we're not, I don't want to be too prescriptive. It's like, reflect on what I say, reflect on your peers, and then as you're going to write it and reflect, choose what you like, choose what you think will make the lesson better, okay? But really super outstanding job. I really loved it. Next week we have, let's see, I'm gonna stop recording. Okay, I will be sending you this this file for you to look at. Both of you should keep it. You'll be writing up your own individual critiques. So next week we got I got my list. Where's my list? Everything's moving all over the place. I got like piles. Okay, there it is. So I got Dimitri and Katerina. You are going next week, and your audience is Ashlyn and Melissa. So that's one group helps you, and now you help them. We will be going after the lesson. Since we kind of know the format, we're going to be moving a little bit faster in terms of our critique, since this is the first time we did it. But we will be looking at what do you have to write up, okay? So really don't miss next week. It's an important week. I might be able to go over it a second time, but it's really I really want to outline, look at the exact pages that you have to read, what you exactly have to do, and so that you could hand it in, okay? Do you guys have any questions? Okay. I like the participation. I won't be as structured next time. I'm just going to open up to you and say, what do you like? What would you like to do differently? I'm not going to structure it as much. I might put you guys in groups to get you guys talking a little bit more, but this is what we're trying to do. You're kind of like a deep dive, give them a lot of feedback. Okay. So you might not get as much feedback in the entire Hunter program, as much as you get in this class. So we spent probably over a half hour on giving you feedback. So that's valuable, really valuable. Okay. And hopefully you're going to elevate. And so in methods too, guess what we're going to be doing? We're going to be doing lessons, but we're not going to be doing inquiry. We're going to be doing other instructional strategies too. Okay. Any questions? We're going to be logging off. Any questions about before we say goodbye? I just want to take attendance. As I take attendance, you guys could log off. If anyone wants to hang out, just stay on and we could have a conversation, okay? But really good job, really outstanding. You really should be proud of yourself. This is a great way to start the class. And this class is about you, okay? This is your teaching. This is your lesson. I consumed about maybe five lessons. The next 10 are all about you guys. So, this is a great model that you guys you're teaching, and I look forward to good things. Okay, so this is we're right on we're headed in the right track. Pick out a lesson that works. Pick out a lesson that works. That's the key thing. Try to have it quantitative. Okay, keep it simple to 3 vocabulary words. Do the script. Determine if you want to put the vocabulary before or after, and just do one section at a time. And when you put it together, if you practice it, it will show and you'll have an amazing lesson. It's very doable, but you have to put the effort in. You have to search the internet, get a good lesson, something very inexpensive so your group can buy the materials and do it. You got to get the bugs out. You have to do it yourself. So if you want to bomb, don't do it yourself. Don't practice. Okay? That's the sure way of doing it. Like, don't do the experiment. That's how you go down a bad road. So do the experiment, keep it simple, 3 vocabulary words, and you'll do wonderful. Okay? One piece at a time. One piece at a time. If anyone ever wants to use a different medium like Nearpod, you could use that too. You don't have to be, I'm not going to pigeonhole you into Zoom. Okay. Okay. So once I mention your name, you guys are out of here. Veronica, have a good night. Thank you.
Have a good night.
Okay. Stacy is absent. Dimitri, got you. Jonathan, I think, yeah, there you are up top. Okay. Wasim, Brady, Samuel. I don't see Sam.
I'm right here. Professor. Yes.